Guess who's back? Back again. You and me. Back more for parametric equations. I hope you're sold that parametric equations are way more cool. It's almost like 2 plus 1, you know? We used to just see a graph and it would show us one thing, but now it shows you like multiple things, multiple layers, just with like a little symbol, like an arrow, right? Now, check, oh, parametric. Look at the spelling right here. Sorry about that. You know what I mean, right? Parametric, okay? Sorry about that. That's kind of embarrassing. Parametric equations, okay? Now what we're going to do, we're going to plot. Now, if you look at this graph here, do you know exactly what that looks like? Before, when it used to be like something as simple as y equals x, we're like, oh, we know exactly what that looks like, right? But parametric, you're right. At first glance, it doesn't look like what you are used to, the kind of curve that you're used to. But it's amazing what it can create. So why don't you do this? Why don't you stop the video, plug in your value t for this, and see what you get for x and y, and see what kind of graph you predict. See what kind of graph you produce. Maybe make some predictions. What do you think it's going to produce? Stop the video now. Go! Okay, welcome back. So, did you get something like this? When I plug in a 0 into cosine of t, I get 1. When I plug in 0 into sine of t, sine of 0 is 0. All right, so did you get pi over 2? Cosine of pi over 2 is 0. Sine of pi over 2 is 1. I got pi's, negative 1, 0, 0, negative 1, and 1, 0. Is that what you got? Because we're so good with our trick now. Let's start plugging it in. If x is 1, y is 0. X is 1, y is 0. There's my t equals. Remember, we're supposed to label our t's, right? That's when t equals 0. Let's go to 0, 1. 0, 1. 0, 1 when t is pi over 2. Okay? T is pi over 2. Negative 1, 0 when t is equal to pi. You know, this is kind of telling us the direction that it's traveling in, right? So you know what I'm going to start? Well, let's actually plug everything, but I like that we're writing the values on it as we go, because it tells us which order that we need to connect what to. For example, I know that I have to go from 0 to pi over 2 to pi over pi. And then I probably have to go 0, negative 1, right? Because that's when t equals 3 pi over 2. It's going in the order. And then you also have t equals, pi over 2, 1, 0. 1, 0 here. So that's going to be t equals 2 pi. All right? Now, let's go and connect the dots in the order. Did you get something like this? And you're right. Some of you guys might be thinking, well, I don't know if it's going to be a curve, a perfect diamond, maybe. Maybe some of you guys were like, ooh, yeah, okay. Well, if you are questioning that, you need to plug in more coordinates between that, okay? And then that'll be clear to you. But guess what you see? Did you ever think that this was going to produce? So watch. This is a very famous one, actually. Y equals sine t. This is same thing as a circle. Dun, 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 dun. Did you think that it was going to be a circle? So later we're going to do something where that just shows you that this is going to be a circle somehow. And it'll be really pretty cool for you, okay? So that is a circle. And maybe you didn't know it, but it's okay. Later we're going to do something to it. Ooh, okay, excited. So pretty cool, right? Now, why don't you try, I'm going to give you one more to try on your own. Try x equals t example. Okay, bonus example. X equals t squared minus 4. Y equals t over 2. And I want you to try that and compare it to x equals 4t squared minus 4. Y equals t. And I want you to only try this one from negative 2 to 3, and this one from negative 1 to 3 over 2. And we'll discuss this later, okay? Go ahead and plot both of them, and then we'll discuss this in class. All right? Now, something to question is this. Do they look different or same? How are they the same? How are they different? What is the difference between them? What is the same about them? Okay? All right. Thank you. Let's go on to part 2. Oh, stop the video if you want to try this one now. And come back to part 2. Oh, welcome back to part 2, eliminating the perimeter. Wait, we said we were going to eliminate the parameter here somewhere, right? The parameter is a third variable, not your typical x and y, but it's actually your t. Or sometimes maybe some other parameter, right? Whatever you want to add. But let's see how we do that with this simple one here. Okay, right now, what does eliminating parameter do for you? Why is it beneficial? And you'll be able to answer that question once we're done with this one example, actually. Eliminate the parameter and identify the graph of the parametric equation. You're like, I don't know what this graph looks like. Do you know what this graph looks like? Maybe you're quickly calculating things in your head and you're like, I don't know, right? For example, no one could predict that this was going to be a circle. Okay? No one. No one. Maybe some of you? I don't know. Okay? All right. So you know what? Maybe we should do this one first because I feel like all of you guys are thinking, what if I asked you, write an equation of this circle with the radius of 1. And I think a lot of you guys would be able to do that, right? So let's see how we can do that by eliminating the parameter, per se. Okay, so let's first start with something like this. I think everyone in here knows that if a circle starts at an origin of 0, 0, then your equation of this particular circle is this. Any circle with a radius of whatever r, and your center is 0, 0, then it's this standard form, right? Okay. Now, but you also know, you also learned something here. In our case, here's our x and here's our y, right? Isn't our x cosine squared t? And isn't our y squared, because our y is sine t, but it's squared, so it's sine squared c. And what's our radius? It's 1 squared 1. Whoa, 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 whoa. So we know this already, but we know this because we can replace x with our cosine and y with our sine because it's given here, okay? Even if we didn't know this, it's okay. Because when we're eliminating the parameter, our goal is to eliminate the extra parameter, which is a t. The x and y, we need it, right? We always write in terms of x and y, right? So let's actually try doing this. Okay, so wait. So then that means, wait. Let's do a lot of things here. X squared, y squared is equal to cosine squared t plus sine squared t. We know that too, right? Like we're just writing a lot of the things that are true statements, okay? Whoa. We already got our x and y squared, right? But don't we also know that cosine squared t is equal to 1 squared? So doesn't that mean that xy squared plus x squared plus y squared equals 1? Oh my gosh. We've just eliminated the parameter. Without even like really doing anything. We've eliminated the parameter, right? So we now we've followed all the rules, algebraic rules, and we were able to get this. What is this? Let's say you didn't graph it, right? And you took this and you eliminated a parameter. Can you answer the question now? What is this curve? And you'd be like, yeah, that's a circle with a radius of 1. In which means you can probably have sketched this without actually following the parameter, right? But if you do follow the parameter, you get these little nice directional arrows, which tells you which way the circle was traveling. Because perhaps the circle could be traveling this way also, right? But in this case, the circle travels from here to here, right? And that's what the parameter actually shows us, more information, right? Rather than just drawing this a simple triangle, a circle here. But do you see the power of eliminating the parameter? So we'll continue with this one as well on the next video.